So warm-up number 81, pretty much it's the same as the warm-ups that we've been working with throughout last week, continuing on today. And like I said, this week we're going to finish up with Module 8, and then we're moving on. Let's go. Let's go. We're going to move on to exponential functions next week. And then from there we're getting into logarithms and all that fun stuff. Oh yes, let's go. We got this. So for number 1, let's see. Let me go over this one just to make sure we got the entire process. Make some space here. So, to evaluate, should have done f of negative 1 equals 2 to the negative 1 minus 2. Is that correct? Which is f of negative 1, which is 2 to the negative 3, which is f of negative 1, which is 1 over 8. Hands if you got that. Okay? And once again, how do we get there? We can't have a negative exponent. We put that over 1 and do the reciprocal. Make sure you're following that process. Guys, I'm giving you like the basic skills before we get to the exponential and the logarithm, so you need to practice these. Okay? From there we got f of 0 equals 2 to the 0 minus 2. F of 0 equals 2 to the negative 2, so f of 0 equals 1/4. Hands if you got that. Okay, good. And we got f of 1 equals 2 to the 1 minus 2. F of 1 equals 2 to the negative 1, so that's f of 1 equals 1/2. All right, so we should be able to do those. So with the process the same as for these, so f of negative 1 is 1 over 100. Yes?
Yes.
And then f of 0 equals 1 over 10.
Yes.
And f of 1 is 1. Let's go. Yes. Okay. Yeah, we got this. All right. Let's go to number 2. Number 2, once again, I've been giving you these just so that we can get your brain ready, because today we're just going to add a couple more things to transformations, and now we should be on automatic pilot. So hopefully with the things that we've been practicing with the warm-up, it's going to kick in with what we do today. So here we go. So let me graph this just to make sure we got it. Our parent function, we said all parent functions go through the point 1, 1. Is that correct? So this is a cubic, and it looks like this. Okay, so according to the transformation here, we put a little cube right there. We know it's going to go up because of k and to the right because of the h. Is that correct? And we know that this too, by now, we should see that it's going to stretch it. That means instead of being at 1, 1, now it's going to be at 1, 2. That's what it does. It's a multiplier, so it multiplies a 1 to a 2. So now the stretch looks something like this. And now that we stretch it, now we can move it 5 to the right and 3 up, 5 to the right, 3 up. So that means we have our point of origin, our stretched point. So it should see something like that. Hands if you got something like that. Okay, good. All right. And let's see, example 3, we got a to the negative 1 is 1 over a. 9 to the 0 is 1. And this one, if we distribute the exponent, we got 1 to the negative 2, 7 to the negative 2. We can't have that. We do the reciprocal. So we end up with 49. Hands if you got that. Okay, so far so good. Let's go. Then we got 4 to the x plus negative 2. Becomes 4 to the x times 4 to the negative 2. We can't have a negative, so we end up with 4 to the x over 4 to the second, which is 4 to the x over 16. Hands if you got that. All right, just like some math judo there going on. All right, agenda for today, warm-up number 81, rational functions. Today I'm only going to give you 6 problems. Only. It's part of the plan. Let's go. So, reminder, tutoring after school, be there or be elsewhere, yeah? How you guys doing? It seems like if it was a Monday, but it's Tuesday. Come on, guys, let's go. Was that a good 3-day weekend? Yeah? We needed to rest, yeah, some of us? Do you guys do anything on the weekend? Like, no? You're like, we do homework for our other classes. Oh, good. Supposedly. All right, Hector. All right. So, previous home play was 396, 397 before Friday. That was the last home play that you had, yes. And tonight's home play, take your phones out, take a picture of that really quick. It's only 6 problems, and it says rewrite the function if possible, graph and identify domain and range. And if anybody's absent that you know, just let them know to go to the YouTube channel, and it's in the video lesson, yeah, at the end of the day. So it's only 6 itty-bitty problems, and if you notice, they look pretty familiar with what we've done before, except all of a sudden when we get about right here. This looks a little bit different, yes? All right. So, with that said, Cornell notes, here we go. I can write, solve, and graph rational functions. I can write, solve, and graph rational functions. So as we continue the same concept as we started last week, that's why we don't need a Frayer model. And of course, by now you know the definition in your own words, yes? And you can think of an example, an unexample, hashtag. If you go to that Who Wants to Be a Millionaire, if this was your last question to be a millionaire, and they asked you, what's the definition of rational functions? There you go, $1 million. One of these days I'm going to show you, I have a saved video of that game, and this college guy, he needed this one math question to move on to the $1 million question. He needed that one to get $15,000 and then move on to the $1 million question, and he got it wrong. And it was a 7th grade pre-algebra question. I was like, oh no, he didn't do that. All right, so rational functions, we know what they are, yes? They are equations with what? With fractions, yes, and they look something like this, yes, and so on and so forth. Non-examples, hashtag, we got all that. From there we talked about steps that we covered, yes, easy steps, yes. For graphing, we just added long division to rewrite some of those equations. And then to write equations, we were given a graph and we needed to follow this process to find the equations or write the equation from the graph. So from there we went to, we said, this is our general rule, now we are here. And one thing that we notice is that we have 1 over x and something, if that's our h. And what does the h and k stand for? They stand for asymptotes. And what did we say asymptotes were? Invisible lines that our graph does not cross. So last week I said we were going to be doing or working with the easy ones, which was a vertical and horizontal. Today and tomorrow we're going to continue with these, but then by the end of the week we're going to move on to the funner ones, which are these, the oblique. Yay! So we know that h is our vertical asymptote, k is our horizontal asymptote, yes? Okay. And then we went on to do something like this, yes? And then from there we moved on to something like this, yes? Where we needed to do a long division and rewrite it to make it look like the other. And then we did something like this. And of course you had home plate for all that. And then, and so on and so forth, yes? Okay. So we went to writing an equation given a graph. They gave you the form. You wrote that down, started filling out information according to the graph, and so on and so forth. Yeah, so far so good, yes? Everybody enjoying this, yeah? Okay, yeah. Good. Just yes. All right, so before we move on, let's see how yes that is. Here it goes. So we know that our parent function, f of x, look up to the screen, don't copy this, or rationals is like this. What is so important about that? That we have 1 in the numerator. There cannot be any other number except what? 1. And then if it's a negative, whatever, we move that to the front. If there's a different number, we move that to the front and just put 1 on the numerator. But the bottom has to have an x. Yes? And that graph looks like this. This is the parent function. And here's my coordinate plane. All right, let me straighten that out. My goodness. Better? Yeah. Kind of, sort of? Yeah, okay. Oh my goodness. Okay, there it is. All right, so what points are always part of the parent function? 1, 1. Okay? And for this one, what it reflects is -1, -1. Okay? Are we there so far? All right, put on your thinking cap. Ready? If I gave you g of x you're basically just taking this and doing a transformation. So according to this transformation, where are we moving all of this to? Talk it over to your neighbor. Where are we moving it to? So hopefully you still see that this is h. It's going to move it to the right, what? 3, and then 5 up. So basically, this is what I'm talking about. Look up, please. I'm taking this whole thing, the whole thing, including the x-axis and the y-axis. I'm going to move it 3 to the right and 5 up. But instead of having the coordinate plane solid, it's going to be a dotted because it's going to be our asymptotes. Does that make sense? Yeah. Let me repeat that again. Let me bring this down again. The transformation, yes, we're going to follow the steps, and basically all it's doing, it's moving this 3 to the right, 5 up, but once we place it over there, the x and the y axes become what? Dotted, because they become our asymptotes. Yes? And that's why, if you can tell, this is our x asymptote, which is 3, and this is our y asymptote, which is 5. It's still going to move to that spot. Okay, so far so good. What if I gave you this? Talk it over here, let them know what's going to happen to that original one. All right, everybody ask Pedro what's going to happen to that one. Okay, let's stay focused, please. All right, what does this do, everyone? Stretch vertically, yes? So instead of being at 1, 1, where is it going to be now? 1, 2. So I'm going to be up here, and my graph would be something like this. But the point has to be at 1, 2, which means this one's going to be at what? -1, -2, somewhere down here. Does that make sense? Yes? Okay. All right. Next. What if I did this? Look up. Tell your neighbor what that's going to do now. Good conversations. Jasmine, go. Stretch it, which we already did, and now it's going to flip according to this negative, yes? So instead of being at 1, 2, it's going to be now at 1, -2, and this one at -1, +2. So this one flipped in this direction and in this direction. Everybody following so far so good? Yes? All right. And so on and so forth. And if I was to put this as a fraction, then what is it going to do? It's going to compress it a little bit, and so on and so forth. All right, so, but notice that it doesn't change the graph. It's either, oh, my goodness, sorry. It's either like this, it stretches it, or it flips it. Yes? Okay. So, with that said, on your paper, copy this, please. Example 3. It says, rewrite the function and graph and identify the domain and range. And we are given g of x equals 1 over x squared. And for the sake of this, make a coordinate plane from -5 to 5, please. On both the x and the y axes. All right. So, what do you notice different of this function? Talk it over your neighbor. What do you notice different? Still irrational, but what is the obvious thing that is there? The exponent, is that correct?
Yes.
Which means it's going to do something to the original rational function. Let's find out what it does. So for that, just so that you can see where we're at, let's make a table. Let's do x, g of x. All right. And this is just so that you can see where the new graph is going to look like. Okay? So this is going to be our new parent function of a rational. But I'm going to leave it as g of x because f of x will be without the exponent, yes? All right, so I'm going to go -2, -1, check this out, -1/2, 0, 1, oh no, not 1, 1/2, my bad, yeah, 1/2, 1, and 2. All right, to graph this, let's get started. What is the first thing we always do? We identify our what? Our VA and our HA. Say never what those are, please. VA and HA. That is correct. 0 and 0. There's no number here, no constant, and there's no number next to the x. Still the same process, okay? So let's identify those. X, 0 is right there. So we do a dotted line going straight down through the y-axis. And then again, the 0 is right there, and the dotted line going through over the x-axis. There it is. Okay. Next, let's substitute values. It's going to go a little faster, yes? Here you go. -2. What is -2 squared?
1.
So this is 1/4. -1. What is -1 squared?
1.
1 over 1 is
1.
1. Okay, and I wanted to get to this part though. I'm going to substitute 1/2 in there. So 1 over -1/2 squared. All right. Let me zoom in so I can do the work for this, because then it's going to get pixelated. I'm going to do 1 over -1/2 squared. Okay. So, 1. What is negative times a negative? Positive. What is 1 times 1? 1. 2 times 2? 4. All right, this looks funky, right? But I already addressed this in the past, and also last week on the home plate with one of those that you needed to write on the B, you ended up with a fraction. Hopefully, you know, You got to those? Well, how do we get rid of this fraction? What does this mean? This means, let me show you right here, this is 1 divided by 1/4. Do you agree with that?
Yeah.
Which means this becomes 1 times what? 4 over 1, or 4. Which means this is 4. Now, in order to avoid doing all of this, whenever you end up with a fraction on the denominator, all you have to do is what? The reciprocal. Does that make sense? Look, 1 over 4, so what is our answer? 4. That's the reciprocal. All right. Therefore, see what I did there? All right, so that goes right here. Let's see, 0 was what?
Undefined.
Undefined. Okay. 1/2. 1/2 squared is 1/4. Is that correct?
Yes.
So that means this is what? 4. And then if we substitute 1 squared, 1 over 1 is 1. 2 squared is 4, so that is 1/4. All right, let's plot those points. Here we go. -2, 1/4. -1, 1. -1/2, 4. All right, let's graph this side. All right, now let's do the other side. 1/2, 4. 1/2 of x, 4 of y. 1, 1. 2 and 1/4. So, notice this point though. Look up. What is this point? 1, 1, because it's the parent function. Okay? So what's the only thing that moved from the original parent function 1 over x to this one? What do you guys notice moved? The left side of the graph, right? Check this out. Look at this one. All of that happened. We brought this one up, and it did the inverse. Here it goes. You guys see it? Okay. So for tonight, I am going to ask you to identify the domain and the range. So let's identify domain and range on this one. You're not going to have to do a table. I want you to graph it just using this point. Look up. This point and that point, but with a transformation. And we'll get to that in a little bit, okay? So for example, if I was to say for tonight, graph this without a table. Tell your neighbor the first thing you would do to graph that without a table. What is the first thing? All right, hold on. Let me do this again. Let's say I gave you this right now, as is, to graph it without a table. Right now there's nothing here. What would you do? Okay, let me put it like this. I drop you off in the mountain. There's nothing there. There's no communication, and you need to go poop. And in order to get off, you need to graph this. Okay, what is the first thing we do? Asymptotes. VA, x equals 0. HA, y equals 0. Okay, so this is going through there. Sorry. All right, and going through here. All right, so next, can we graph this without a table? Yes. Tell me what to do. 1, 1, and where else? -1, 1. And then I just do this and this. Is that correct?
Yeah.
Yes? Okay. But then they're asking me for what? Domain and range. I wanted an interval. All right, let's find that together. Interval notation. So here we go. Domain. Here we go. So look at the x values. This arrow indicates that it keeps going which way? To the left. That means it keeps going to what? Negative infinity. That is correct. And if I keep going to the right, where would it stop? At 0. So it's negative infinity to 0, and it's parentheses and parentheses. Why? Because we never get to infinity, and the 0 is not included because it's what? Undefined. Okay. Am I done though? Let's jump over that and then what? Continue with what? 0 to what? Positive infinity. Now check this out. That is true, what we just wrote, but in order to say that they're both together, we put a U in between, meaning union of those two. That's the domain. Let's do the range. From the bottom to the top. I'm going from the bottom. Where do I start? At -7? No. -6? No. Tell me where to start. At 0? Yes. So this would be 0, comma, and it keeps going to what? Positive infinity. Bracket. Is there anything else? No, that's it. That's the range. How are we doing? So the only thing, check this out, the only thing that's going to change, guys, is going to be this number, and that number for all the others. Because if I move this, let's say to the left, so guess what? It's going to go negative infinity to whatever number, and from whatever number to positive infinity. Yes? But do you see how this looks now? Yes? All right. So what does that mean, Mr. Q? That means, look up, that in the denominator I need to have something squared, or at least x squared. Now check this out. One more thing before we move on to the funner ones, yeah? Here we go.
Oh, yeah.
What if I had this, g of x, and I asked you to move it according to tell your neighbor what's going to happen to this whole thing according to that. Everyone? To the right. That is correct. What if I said this? To the right and 7 down. That is correct. How about these 2 points if I did this? Tell your neighbor what would happen to this point. Where would this point be?
1, 3.
At 1, 3. That is correct. And negative 1, 3. Does that make sense?
Yeah.
All right. So, enough of the easy stuff, yeah?
Oh.
Let's move on. Example 3Q, copy this one. So, let's graph this one, but without a table. Ooh, let's go. Okay. So, now, just so that you can guide yourself, I'm going to help you with this part. Me, Mr. Q, is going to graph g of x equals 1 over x squared. Okay, which is right here at 1, 1, negative 1, 1, and of course my asymptotes are here and here. Okay, that's the original. So tell your neighbor what's going to happen now with this and all of that. Talk it over to your neighbor, please, and graph it. see. Alejandro, what's going to happen? 2 to the what? 2 to the right. Hands, have you got that? That is correct. That means we're going to move everything 2 to the right. So, check this out. That means this asymptote stays the same. That means I need a new asymptote at what? At 2. Let me do that in green so like that we know it's a different one. My goodness. Okay. So here we go. So that means that my HA is y equals 2, which is this one. Okay. And my VA, it's still x equals 0, which is over here. Yes? Okay. However, check this out. Where am I going to place this one at? Tell your neighbor, where will this one, tell them the coordinates. If the asymptote's at 2, what would be my new coordinate for that point?
3, 1.
That is correct. 1 to the right, which is 3, and 1 up, that's 3, 1. That is correct. That means on this side, what would be the coordinate for the one on this side? Tell your neighbor, please.
1, 1.
Here's my asymptote at 2. If it's only one step to the left, it would be at what?
1,
1, 1. That is correct. All right. So, now that we did the easy part, let's get the domain and range. All right, domain. I said it's going to the left. Is that correct? So that means it's at negative infinity. But where does it start? I mean, where does it stop? It stops at 2. Does it include 2? No. And then union, what else? 2 to what? Positive infinity, yes. And range, since our HA is still at 0, that one is still 0 to positive infinity. Woo. From 1 to 5, I'll come to borrow you with these. Yeah, 5 fours, 5 fours, yes. So let's do another one. Here we go. Now, I hope you're seeing, look up really quick, that at the denominator we need to have an x squared or x in parentheses with something squared, yes? Or in other words, we need something in a factored form squared, yes? Something in factored form squared? Okay. You're like, what? Yeah, because what if we have something like this? No, not yet, but let's copy this one really quick. And for the sake of time, we're not going to find the domain and range on this one. We're going to keep moving. I just want it graphed. So here we go. So this one, example 3 mega q, they give us g of x equals negative 1 over x plus 3 squared plus 2. Let me get our coordinate plane. And once again, for the sake of you seeing where I'm at, I'm going to graph the parent function here. This is my HA, my VA. Oh. Oh my goodness. There you go. There it is. And my original is at 1, 1, negative 1, 1. Okay, so can we have a negative 1 on the numerator?
No.
No, we need to rewrite this. So this is g of x equals, what do I do with this negative, guys? Tell your neighbor, please. What do I do with this negative? Yeah, move it to the front. So this would be negative 1 x plus 3 squared plus 2. All right. So, here we go. We know where it's going to move, right? All right. So, here we go. Let's identify first our VA, HA. Okay, tell your neighbor what the VA and HA are. Okay, vertical asymptote is this one, which is -3, and our HA is 2. So -3 of x, we got -1, -2, -3. So that means it's going through there. Okay, and our HA is at y equals 2, so this is 1, 2, so it's going through there. Okay. Okay, so with that said, before I move it, which direction? 3 to the left and 2 up. Before I move these 2 points, 3 to the left and 2 up, we need to do this first. And I'm going to do that in black. So where would these 2 points go according to this? Tell your neighbor, please. Where would those go? Yeah, I heard some of you saying the bottom. Yeah, so this would be at 1. Instead of 1, it would be 1, -1. And this one at -1, -1. So we flipped it. I'm going to make dotted curves so that I know that it's not completely done. That's where it's at so far. And now we can move this, what? 3 to the left and 2 up. So these 2, I'm going to move 3 to the left. 1, 2, 3, 1, 2. So far so good, yes? And this one. 1, 2, 3, 1, 2. And from there you would find the domain and range of that one. Okay? From 1 to 5, how far are you up to right there? Now, have you noticed that the practice that we've been doing on the warm-ups with the transformations, it's kicking in, right? It has to kick in. You guys need to be doing that practice, guys. It's part of it. All right. Who? Hector? Okay. And Davin, don't forget at the end, come get this. All right. So, we're good up to right there. All right. But what if I gave you something like this? Copy that one, please. And they give us example 3 super Q, rewrite the function and graph. They give us g of x equals -2 over x squared plus 8x plus 16 on the denominator, and then our constant would be plus 7 at the end of that fraction. Okay. Look at it. Does this look like the previous one? What do we need instead of this? We need in the denominator what? A parentheses what? Squared. So talk it over with your neighbor, let them know what would you do to this to make it look like that. That is correct. So we go 16 and 8. That means what 2 numbers multiply to give me 16 that add up to give us 8? 4 and 4. So my factors would be x plus 4, x plus 4. What's another way of writing x plus 4 and x plus 4? X plus 4 squared. That is correct. Next, can I have a -2 on the numerator? Where do I move that 2? Get it, 2? To the front, -2. So what stays on the numerator? A 1. And then we have plus 7, and all that equal to g of x. Woo! Let's go! All right, so let's graph this. Let's get a coordinate plane going over here. This time I'm not going to give you the original. just so that we can make a clean graph. Here we go. First thing we do to graph is what? VA, HA, everyone, our VA, -4, that is correct. So that we go 1, 2, 3, 4. HA, 7, so that would be 1, 2, 3, 4, 5, 6, 7. Okay, let me bring that down. It's not going to fit on mine. I love technology. Love it. 1, 2, 3, 4, 5, 6, 7. That means I need to extend this one. All right, there it is. So once again, just to remind us, this is at 7, this is at -4, okay? Next, let's see. The original points were what? 1, 1, and -1, 1, yes? What does this do to it? So then my points would be what? 1, -1, and -1, -1. Okay, so now they're down here. All right, so tell your neighbor where to move. Oh, yeah, wait. Before that, my bad. Yes, it's going to flip it, but before that, what does this 2 do to them? Moves them up to that point, which means it's going to be down here at -2 and -2, yes? Now we move them what? Move them what? 4 to the left and 7 up. So we go 1, 2, 3, 4, and then we got 1, 2, 3, 4, 5, 6, 7. So that means from 7 we should be at 5 now, at 5. And on this side again, at 5. So our graph is down here. Whew. Do we know how to find domain and range? Yes? All right, from 1 to 5, how comfortable are you with these? Yeah, 4, 5, 4, 5. So once again, guys, the main idea is to make it look in a factor form for the denominator, which means if you get a trinomial, you need to factor that trinomial to give us that last piece. So the home plate once again, let's see, 6 problems. These 4 are for practice, and these 2 are for practice for what we saw today. Okay? Once again, tutoring today after school, be there or be elsewhere. Enjoy your home plate. See you guys tomorrow. Bye.